Welcome to Lead Electrical Academy. Today I will discuss the most important connections, that is star connection. One more connection is delta connection. So I am taking a 3 coils. Let's say the starting end is R and the finishing end is R dash. 3 coils I am taking, and one more coil is Y and Y dash, and one more coil starting end is B and finishing end is B dash. So based on the connection between these 3 coils, we can say that either it is a star connection or delta connection. So the physical displacement of the winding should be 120 degrees. So all the finishing ends of the coils are connected to one common point. Say this is R phase and this one is Y phase and B phase, and the finishing end of the R is R dash, finishing end of the Y is Y dash, and finishing end of the B is B dash. All the finishing ends of the connections are connected to one common point. Thus this point is called the neutral, and neutral is represented with capital N. So if you are going for the 3-phase waveform, so I am drawing the 3-phase waveform like this. So this one is R phase, Y phase and B phase. So R phase, Y phase and B phase, and all the windings are displaced by 120 degrees. The angle between the R and Y, R phase and Y phase is 120 degrees. The angle between the Y phase and B phase is 120 degrees. The angle between the R and B is 240 degrees. The phase sequence is RYB. And if you are going for the anti-clockwise direction, that is plus 120 degrees leading. So the voltage between phase and neutral is called the phase voltage, VRN. The voltage between the R phase and neutral is VRN. The voltage between Y and N is VYN, and the voltage between B and neutral is called the VBN. So this VRN is equal to VYN and VBN. We can call it as phase voltage. The voltage between the R phase and neutral is called the phase voltage, and the voltage between the two lines is called the two phases is called the line voltage. This is VRY, and this one is VYB, and this voltage is the voltage between the B and R is called the VBR. We are following the RYB phase sequence. So we can write as a VRN is equal to Vmax sine of omega t. As I am taking the x-axis is omega t, and this is a voltage. So VRN, and this one is VYN, and this is VBN. These are all phase voltages I am representing here. So this is a 30 degrees and this one is 150 degrees. 0, 30, 60, 90, 120 and 150 degrees. After 120 degrees Y phase goes to positive, and after 240 degrees B phase is going to the positive. 150 plus 120 is 370 degrees. So VYN is equal to Vmax sine of omega t minus 120 degrees, VBN is equal to Vmax sine of, it is lagging at an angle of 240 degrees, or Vmax sine of omega t plus 120 degrees. And this I can write it as Vmax at an angle of 0 degrees, or we can represent in terms of RMS value V at an angle of 0 degrees, and this is V at an angle of minus 120 degrees, and this one is V at an angle of plus 120 degrees. This is VRN, VYN, and this is VBN. So as I am representing in the Phasor diagram, I am taking the reference is VRN. The angle between the VRN and VYN is 120 degrees. VYN and VBN is also 120 degrees. This is 120 degrees. VRY is equal to the voltage between the two lines, VRN, and this voltage is VNY. So I am taking in the reverse manner. This is VYN. The voltage between the Y and N is VYN. The voltage between N and Y is VNY. Now VRY can be written as VRN plus VNY. VRN plus VNY, and VNY is, it is a potential difference of VN minus VY, and if you take a minus is common, that is VY minus VN, I can write it as VNY is equal to minus VYN. Now VRY is equal to VRN minus VYN. Similarly, VYB is equal to VYN minus VBN, and VBR is equal to VBN minus VR. These are all the line voltage, and the VRY is equal to VYB is equal to VBR can be written as line voltages. So by seeing this diagram, we can tell that the phase voltage and line voltages both are different. The current flowing through the phase is called the phase current IR, and the current which is flowing through the winding is called the phase current, and IR is equal to I phase, and we can call it as IR is equal to IY is equal to IB is equal to line current is equal to phase current. In a star, we can tell that line current is equal to phase current, but the voltages are different. Phase voltage and line voltages are different. So I am representing here VRY is equal to VRN minus VYN. So minus VYN, exactly it is 180 degrees to the positive VYN. So this is minus VYN. The angle between these two is 60 degrees. By adding these two vectors, then I will get the line voltage. Draw a line which from this minus VYN, draw a line which is parallel to VRN. The length of this one is VRN, and draw a line which is parallel to minus VYN, and by adding these two phasors, then I am getting line voltage is VRY, that is VL, and VRN is V phase. Now the angle between these two is 30 degrees. It will cut exactly half. By using a parallelogram concept, VRY is equal to under root of VRN whole square plus, I am taking only magnitudes, VYN whole square plus 2 times of VRN into VYN cos of angle between VRN and VYN, that is a minus VYN. So Vrn square is equal to, that is V phase square plus V phase square plus Vrn is S2 into V phase square cos of angle between these two Vrn and minus Vyn is 60 degrees cos 60 degrees. And what is the cos 60 value? The cos 60 value is under root of V phase square 2V phase square plus 2 into V phase square into cos 60 is 1 by 2 and 2 will be cancelled. Now I am getting 3V phase square, and from this I am getting Vry is equal to VL is equal to root 3 times of V phase. The relationship between line voltage and phase voltage is line voltage is equal to root 3 times of V phase, and the V phase is equal to VL divided by root 3. So 1 by root 3 is 0.577 times of line voltage. If I want to draw the phasor diagram for resistive load, the current is in phase. The angle between the line voltage and phase voltage is 30 degrees, and the line voltage leads phase voltage by 30 degrees in a star connection. And if it is a lagging load, the angle between the phase voltage and IR, it is phi. The angle between the line voltage and line current is 30 plus phi for lagging power factor of the load. If it is a leading power factor, the angle between VL and IL, if it is a leading power factor, so this is IR, the angle between these two is 30 minus phi. Okay, and if you want to represent VYB, so VYB means Vyn minus VBN. So minus VBN is exactly 180 degrees. This is minus VBN. By adding these two vectors, draw a line which is parallel to Vyn, and from this draw a line which is parallel to minus VBN, and add this, then I will get the VYB, and here it is total angle is 60 degrees and this angle is 30 degrees, and VBR can be represented as VBN minus VRN. So VBN minus VRN, so that V minus VRN is exactly 180 degrees to the VRN, and by adding these two vectors by using a parallelogram concept, so this is a dry line which is parallel to minus VRN, and this is dry line which is parallel to VBN. By adding these phasors, then I will get the VBR, and this is 60 degrees, this one is 30 degrees. If you want to represent for lagging power factor of the load, so this is IY and this one is IB. The angle between VBN and IB is phi, and this is also phi. This is a phasor diagram of star connection. See, you can observe that the line current and phase current both are same, but phase current, phase voltage and line voltage both are different. V phase is equal to VL divided by root 3. So as we know, V phase is equal to VL by root 3 and I phase is equal to IL in a star connection. So V phase is equal to VL by root 3 and I phase is equal to IL. The single phase power is equal to V phase I phase cos phi, but we are measuring the power in 3 phase, so that is 3 times of V phase I phase cos phi. So power in 3 phase is equal to 3 times of V phase I phase cos phi. substitute V phase is equal to VL by root 3, this is in star connection, and 3 into VL by root 3 into I phase is equal to IL cos phi, and 3 root 3 into root 3 is 3. Now power in 3 phase is equal to root 3 VL IL cos phi. Then power in 3 phase is equal to root 3 VL IL cos phi. This power is called the active power. Similarly, in a reactive power, so root 3 VL IL sin phi. So why? Because in a single phase 3V phase I phase sin phi, and for a 3 phase is 3V phase I phase sin phi, and again you can substitute the reactive power. The units of reactive power is var, and S is equal to root 3 times of VL into IL, that is under root of P square plus Q square. P in 3 phase and Q in 3 phase square, and the units of complex power is volt ampere. Units of active power is watts.